Hey folks, Azure Cosmos DB Live TV. I'm your host, Mark Brown. Welcome. This week I've got with us Abhinav Tripathi. How are you?
I'm good, Mark. How are you doing?
I'm doing great. You're located over in our, is it our India Development Center? Is that what it's
Right,
called? Yeah.
right. IDC, yeah, India Development
IDC.
Center.
So we're pre-recording this show because it's what is it? 8 quarter to 9 at night
It's
right now in your place.
yeah, yeah.
Yeah, okay. So it's about a little after 8 a.m. here in the west coast of the US and getting close to 9 o'clock where you
That's
are.
kind of
So
early for you.
it is normal
As
for our team because we're so geographically spread out. We either meet early in the morning or late in the afternoon or evening when we try to do stuff together. So here we are. And this week we're going to talk about our capacity calculator. Is that right?
yeah, correct.
All
Capacity
right.
planner.
A capacity planner, right.
Yeah,
So, all right. Well, I know you wanted to talk about things like request units and stuff. I know this confounds many people, especially new customers. But I don't know if people are aware that we have this capacity planner calculator. It's, I think, quite brilliant and very useful. So I'll have you get started and walk us through some concepts on request units.
Uh, all right. So uh, I'll start with covering a little bit about request units or RUs as we refer to them in short. So a lot of people get confused what are RUs and how to estimate their workloads. And so I'll be covering those things, and then I'll walk you through the capacity planner, or we also call it capacity calculator. So it will give you a good idea about your throughput estimation. So let me start very quickly with a familiar screen. If somebody has used a Windows machine, I think they would have used Task Manager at some point. Mark, are you familiar with this screen?
Oh yeah, I spend a lot of time in here. If I need to kill some process, it's hanging my machine. So typically Outlook or maybe Teams or something else. But yes, I do spend time in.
Yeah. So we see that there are these three primary, things that we notice: CPU, memory, and disk. So whenever a process is running in a machine, these three are required. Some compute is required, memory is required, and then disk IOPS are required. So behind every process that runs, these are the fundamental requirements. So same happens in a database. So whenever we do a read or write, it requires some amount of compute, some memory access, and some uh, IOPS, input output throughput in that sense. So if we were to charge, let's say if somebody comes to us and they say, okay, I have to do a write, how are you going to charge us? So if I tell them that, okay, I'll charge you X amount for CPU and then Y amount for memory and then Z amount for IOPS, it will get very confusing for the user. They'll keep on, you know, uh, trying to calculate how much for compute, how much for memory, and all that. So what Cosmos DB does, it abstracts out these details and it tells the users, okay, uh, there is a virtual currency. So that is what we call request units. So we will abstract out all these details. The compute, memory, IOPS, the user doesn't have to worry about what is happening behind the scenes under the hood. We will tell the users that, okay, we are going to charge XRUs for a read or a write, depending on certain factors. So in our world, RUs is a virtual currency, and it is guaranteed that in Cosmos DB, if you are performing a point read on a 1 KB document in a single region, it will always cost you 1 RU. So it gives you a kind of predictability and relatability, so you can guess, okay, if I have to perform 10 point reads in a single region and the document size is 1 KB, so I will spend 10 RUs, and accordingly you can estimate your expenditure. So those are, the RU is the virtual currency. You pay for RUs, you buy X amount of RUs, and then spend those RUs on read write operations. So this is how the Cosmos DB RU operates. Then you, in any database, there is this term throughput. So what is throughput? So let's say I have an application where I am performing, let's say, let's take an example of a simple portal where users are signing in. So I know, let's say, 1,000 users are signing in per minute, and we have to write their profile data. So they are supplying email and passwords, and I have to write that data somewhere. So in our Cosmos DB world, certain amount of RUs will be spent on each write. So if we have, let's say, 5 RUs for one write, and I have 1,000 such writes in a second. So in 1 second, how many RUs will I require? So the answer comes out to be 5,000 RUs per second. So throughput is basically the rate at which I'll be spending these RUs to cater to my workload requirements. So rate per second uh, of RU expenditure is what we call as throughput. And that becomes very important because when we create our containers or databases in Cosmos DB, we have to come up with a ballpark number. We have to set a number, how much throughput we are expecting on a particular container, how many requests, depending on how many requests, we set this number. So if we set, let's say, 1,000 RUs, and I'm performing 1,000 point reads on 1 KB document, so I will require 1,000 RUs per second. And if I say, if my application gets more than those 1,000 requests, and I have not provisioned enough RUs, so those requests will get throttled. So gets very important for the users to estimate their throughput upfront, at least a good idea about their throughput. And then obviously that's the beauty of Cosmos DB, that you can keep on changing your throughput. There are several modes, and that brings me to the next section. So why estimate throughput? If you look at Azure portal, there are certain settings. You can, share the throughput across containers, or you could specify dedicated throughput for a container, or you could specify at the database level. So this is where you need to make this choice, and hence it is important that calculate the throughput upfront. So when we talk about throughput, we already talked about RUs, like how RUs is a virtual currency that we use for reads and writes. Then we talked about throughput, like the rate at which we consume these RUs. Uh, Now, as I mentioned, it's very easy in Cosmos DB to change this throughput. Let's say I started my application sitting with the 1,000 RUs per second, and now I see that traffic is more than that, more than what I expected. So it's very easy in Cosmos DB by just one click, or just a one API call, and you can actually change the throughput setting. Uh, so that brings us to the question, how do we cater to different kinds of workloads? So there can be uh, basically three kinds of workloads in any setting. One is where that uh, during the course of time, during the day, there is very little fluctuation in the workload. Let's say uh, I'm getting 10 requests this second, 10 requests the next second, 10 requests after that, and the pattern is like that. So I would call it a steady workload. So let's take an example of an IoT workload where there are sensors all over, and those sensors are sending out telemetry data. Maybe let's say temperature sensors in different parts of the city, they are sending out data every 10 seconds. So we know that every 10 seconds there will be let's say 100 or 200 sensors which will be sending data. So we know that every uh, uh, after that frequency we have let's say 200 or 100 data points. So it's quite predictable, it's flat, we know that it's gonna be steady. The other kind of workload is uh, there are some portals, let's say some reservation counters, where people come and book during like the first hour of the day, and then during the rest of the day they are uh, uh, not using the portal as much. So during that particular hour, we will require more database, the throughput, and during the rest of the day, we might not require a lot of throughput provisioned on that. And then there are the third kind of workloads where we do not have any predictability. There might be, sporadic requests. Sometimes there might be some requests, sometimes there might not be some any requests. So those are the three kinds of data, the workload modes that we deal with. So if we go back to the first mode where we have the steady workload, we already know how many requests are coming to our database. So it's very easy for us. If we know that how many RUs will be required for one read and write, and if we know how many reads and writes are going to happen, it's very easy for us to predict the throughput requirement. And that's where the manual provision throughput comes in. Here we set a specific number that, okay, let's say I am expecting 1000 reads per second, so I will set 1000 RU per second as my throughput, and I'll be done with it. So it will be, this setting will be able to cater to all my workload requirements, and I'll not have to worry about it. In manual throughput also, there is an option if, let's say, at some point, uh, it's not gonna be the same. Your business will grow. Maybe tomorrow it gets 1200 requests per second, so you can change the throughput. So in provision throughput, we have two modes. One is the manual provision. The first one that I talked about was the manual provision. You have this setting, you put the actual number, and if you see that requests are increasing or decreasing, you can change that number. So that is done manually. But sometimes it might get difficult for you to do that manually. Let's say you are seeing some patterns during some parts of day, you have bursty traffic, but you cannot predict what part of day you will get that bursty traffic. So you cannot just wait for that traffic to peak and then your request to get throttled and then you increase the throughput. So it might become a very tedious process. So that brings us to the auto scale mode. In auto scale, as you see from this image, you have a steady workflow, and then at some point of time, the traffic peaks. So instead of changing the throughput, the provision throughput manually, Cosmos DB gives us a setting where we can decide, okay, what will be the peak traffic. So let's say, building upon our example of 1000 RUs, where I was expecting 1000 reads per second. Let's say during peak, I expect 1500 reads per second. So in auto scale, I can simply put 1500 as the RU requirement. So whenever the traffic reaches the peak, the setting will automatically scale to 1500 RUs. And whenever it's not at the peak, it will go down at the 10% of the peak. And depending on how much RUs are being consumed, the customer will be charged accordingly. So this saves the hassle of, increasing the RUs manually every time, and tweaking the settings, and uh, it spares you from all those hassles.
Yeah,
And
that's great. So I just wanted to like jump in. Like, there's more flexibility there than even what you're suggesting. Like, if you're if you've got the predictable kind of workload, like you were suggesting, a lot of workloads will have like load during like working hours and then be rather quiet at night. So in situations like that where you kind of know kind of the pattern, if you will, like manual works great. And then you can use something like a timer trigger or something in Azure Functions, and then just scale it up in the morning and scale it down at night if you wanted to. So you don't even need to use auto scale necessarily in there. The other thing you can do as well is you can just call migrate on something. So if you have a workload that's kind of quiet at night and then unpredictable in the daytime, you can migrate. It's just a script, PowerShell or CLI, and you can migrate to autoscale, and then let that run, and then migrate it back. at the end of the day. So you can get the precision, if you will, is pretty high in terms of what you can do and how you can configure this. And like you were saying, like with the auto scale, I mean, you're basically the billing period is like an hour. So whatever your max is within that hour, we'll bill you for it within there. But that flexibility is there where if you want to keep it, if you want to keep it on manual and reduce your cost, you can when you know it's not going to be used. And then you have different options. You can just scale it up using manual or flip it to auto scale and then flip it back again. So lots of
Yeah,
flexibility there for folks, right?
yeah, the
So
possibilities are endless,
yeah,
You can configure it whatever way you want.
yep,
Yeah. So thanks for adding that, Mark. I missed on to that detail. Yeah.
yeah,
So yeah, so the third mode that uh, we discussed was, you know, when there is sometimes there is sporadic workload, and then most of the times it's all dirt. So in those modes, we recommend you can use serverless mostly for your dev workloads. So serverless is different from uh, your provision throughput. In provision throughput, we have to uh, estimate the throughput requirement upfront, but in serverless you pay for what you use. So let's say I have uh, 10 reads today, so 10 RUs will be consumed for that. Let's say I have 100,000 reads tomorrow, so 100,000 uh, RUs will be consumed tomorrow. And mind it, it's a 1 KB document point read, so I'm saying one RU for the read. So 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 serverless is basically per million RUs charge. So accordingly, like whatever you consume, you will be charged for that. There is no upfront throughput estimation required, no throughput provisioning. So it's kind of good for bursty intermittent traffic, which you cannot predict normally. Uh, do you want to add something to this, Mark?
yeah. Like this is my favorite option for doing dev tests because it doesn't cost you anything. I mean, there's charge you for storage, but at a quarter, 25 cents US a gigabyte, that's not really a whole lot to deal with. But
Yeah, ever since this was launched, I always use serverless for my all POC apps.
yeah, same here. And I wish we had the ability to migrate it to provision from serverless. We don't have that capability yet, but
Yeah,
this is still my default go-to when I'm doing dev test.
yeah.
Just simply because why not? it's just, it is the most economical option, and you don't need dedicated throughput. You don't even need auto scale when you're doing dev test. You just need something to handle like your request that you're doing dev test on. So yeah,
Absolutely. We do get one account with 1,000 RUs per second throughput for free limit, but that's just like one account. And with serverless you actually don't need so much, so you can just spin off a serverless account and in serverless throughput mode and just get started with your testing without worrying about
yep,
anything.
yep,
Yeah. So when we talk about throughput requirements, there are a lot of factors that affect throughput requirements. As I said, the primary things are compute memory and IOPS, which we have already abstracted out. But Cosmos DB, we provide different APIs, the open source APIs through Wire protocol, the Mongo and Cassandra, and we also do provide Gremlin API and uh, the table API and our NoSQL offering. So depending on the choice of API, the RU requirements for each operation varies a bit, because obviously all are different from one another in some sense. Then we have the region settings. So Cosmos DB, as one of the best offering in Cosmos DB is just one click uh, geo replication. So you can specify a number of read and write regions. You can increase it or decrease it. So it's very easy. You can do it uh, just with a click. But when you obviously offer your workloads through multiple regions, the cost increases. Then depending on multi-region, right? So one is you just specify the multi-region reads. So you are making your workloads available in different regions so that it is easier for the customers in different geographies to consume the data at a fast speed, but and also to ensure that uh, data for data safeguards. Another thing is multi-region writes. So if you have to write in multiple regions simultaneously, that also incurs some extra cost. Then there will be additional RUs consumed for indexing, depending on your indexing policy. If you are indexing everything or nothing, obviously there will be some RUs consumed, but these are, leftover RUs that those are consumed, not exactly the leftover, but the priority is given to your read and write requests. So after that, whatever is left is used for indexing. Then Cosmos DB offers 5 consistency levels. So depending on what consistency level you choose, strong is the highest consistency level. So there is a slight difference in uh, each operation cost. Then again, traffic variability. If you go for auto scale, it costs a bit extra for reads and writes. Another thing is item size. When we started talking about RUs, I emphasized that it is guaranteed that the cost for 1 KB read in a single region is always 1 RU, 1 single point read cost. So I emphasize on the document size because as we increase the document size, the cost will also change. It's not linear. I mean, it's not like if we write a 100 KB document, the cost will be 100 RUs, and if I write a 200 KB document, it will be 200 RUs. The cost is not linear; it will be less than that, but it does increase with item sizes and the number of properties in items. Obviously, if I'm writing one document with just one field uh, versus one document with 1,000 fields, the cost may differ according to that. Apart from that, if we look at what operations we perform and in our databases, uh, I talked about point read, 1 KB point read. So there's a concept of partition key in Cosmos DB. When we utilize the partition key with our reads, it is a point read. We exactly know which partition we have to look for. But if we are doing queries, uh, depending on how many documents are scanned, what is the results returned, uh, a lot of other factors, the RU consumption for queries will differ. So these are broadly the main parameters that may lead to variability of the throughput requirement.
Yeah, just a couple of comments on some of these with the multi-region rights. I mean, that's you're going to pay double basically what you would pay for single region rights in there, but
Yeah.
it's worth it for some customers that use it because they're either looking for very low RTO, right? So if you've got a issue with a region not accepting rights, SDK will just automatically write it in another region for you,
Hmm.
or that low latency writes globally, like you were kind of touching on there, right? Where you just got data that's distributed geographically and you need to get low latency writes to all of them. That's a good option for folks. The indexing policy, for sure. I think when you hear us talk about like the cost of writing a kilobyte of data, I think what do we call it, 8, 10 RU or whatever, that's an unindexed write
Yeah.
for that kilobyte of data. So, and this is another thing that we provide a lot of guidance on for customers is, hey, when you're getting ready to go into production, you should look closely at the queries you're using. And they're particularly, well, let me back that up. If you have a write heavy workload, you should look carefully at the indexing policy you're using and making sure that queries or that you're only indexing properties that are being used in your queries within there, because you can save a fair amount of RU for these write heavy workloads if you do not index properties that are not used. It doesn't make sense. It's just wasteful,
Right.
basically. And that kind of, and same thing kind of goes with the number of properties in there as well with that. The consistency levels. I don't know if people realize this, but If you were using strong or bounded staleness consistency, you were paying 2x for every
Correct.
read. So a read on a document is 1 RU for session or weaker, but it's 2 RU for bounded staleness and strong. And the reason is because the reads are done from 2 replicas versus 1, and it's a 2 replica read because it's comparing the LSN for that record to make sure that it is strong, to make sure that it's the same. That's how we guarantee consistency, is reading from 2 replicas. You write to 3, read from 2. If they match, great, that's the latest record. If they don't, you take the higher LSN, and that is what's returned to the client. So just some internals there on why those costs are different. But yeah, and then of course with query patterns there, right? This is another huge one, why we talk so much about data modeling and partition key strategy is, if you're running queries with high concurrency that are fan outs, it's just fundamentally not going to scale for you. You're not going to enjoy yourself using Cosmos, I guess is what I would say. So yeah, but
Yeah.
yeah, lots of things affecting it. It's hard. There's lots of things to consider when you're trying to figure out and do this capacity planning for throughput. So
Yeah, so that's why we have the capacity calculator, Mark,
yeah,
because people cannot estimate all these how everything is going to affect. So that brings us to our capacity calculator tool. Let me open that quickly. Yeah. So this is available at this link, cosmos.azure.com/capacity calculator. And it has two versions. One is open for everyone and one is signed in version. So let me show you the public version. And the signed in version is only available for the organizational users. And this version, the non-signed in one, is publicly available. So let's quickly look at this form and see that it has almost like all those inputs that we talked about.
yeah,
So what capacity calculator lets you do is, depending on your choice of API, here you can choose which API you are going to use. So let's say if I have to estimate a workload for NoSQL API. So let's discuss a scenario where I am new to Cosmos DB and I want to see how much throughput I have to provision. So I start estimating from here. So I will have to make a API choice in my Cosmos DB account. So let's say I'm going to choose NoSQL. Then number of regions it asks me, and let's make it one region. When I'm starting my application, I might not need multiple regions straight away. So let's get started with one region. And multi-region rights, we'll keep it disabled for now, because again, I am operating in a single geography. I don't need it right now. Then another thing that costs users some dollars is the storage, but this is not related to RU, so I did not cover it in my slides. The storage is kind of cheap, like 0.25 USD for 1 GB per month. So let's say I start with 10 GB of uh, data to begin with, and that's like the default setting. So let it be. We'll come back to analytical store. So for now, uh, I'm keeping it off. And then workload mode, as we talked about, the manual provision, throughput, auto scale, and serverless. We touched upon this workload mode. So we discussed two scenarios where one was the IoT telemetry, where a lot of sensors were sending data, but it was uh, steady at a steady rate. So every second, let's say, we are getting 200 data points, so we know that it is a steady workload. But then we also discussed about the variable workload. So for how much time it could be variable, that is also a setting. So for the first example, let's consider steady workload. So we made the API choice, the number of regions, and then we chose the workload as the steady mode. So it asked me the sample item. So uh, information about the items, like how many reads I'm going to perform, first I have to specify the size. So in our databases, we can have our items of different sizes. So we might have different types of items that we are storing, and depending on that, there might be different item sizes. Let's a very classical example of student and teacher. If we are storing students and teachers, let's say student data might be 1 KB and teachers data might be 2 KB, and depending on how many operations we are performing on both, the RU requirement might be different. So let's say our item size is 1 KB, and let me put the multiples of 100 so that it becomes easier for us to later look at the numbers. So let's say I'm going to perform 100 point reads, or maybe just let's make it 1000 RUs because that was our example. So, and uh, 10 creates per second, 10 updates per second, and queries I can clear right now. Maybe put it as 0, because query is a number that we have to take an average number. It cannot be estimated depending on the query pattern. It might vary. So this is something we cannot estimate upfront. So if I hit calculate, it will take some time. It will actually execute these operations and it will see. So this calculator also shows you the details of the detailed breakdown of how many RUs are required for each operation. So if we look at, point reads, for 1000 point reads, we require 1000 RUs per second. For creates, the average cost for 1 KB document is 5 RUs, so it requires 50 RUs for 10 creates. And updates, reading and then again writing the document, so it is almost twice the cost of writes. So it requires 99 RUs. So all in all, we require 149 RUs per second. That is the throughput requirement. So if I was, creating a new container in my Cosmos DB account, I know that, okay, for this kind of workload, I will need 150 RUs per second as my throughput. So I'll not have to, over provision or under provision. This gives me a fair idea about my workload requirements. And it also tells you about the monthly cost. So with this workload, you will incur $67 cost for your throughput requirements, and add to that 2.5 USDs for your storage cost, so that will amount to $69.58. So this was a normal single region account. Now if we add a region, how do these costs change? So I can simply click on calculate. So there are a lot of options for the users to play around. They can try out different scenarios, how their costs will be impacted. So the moment we add a region, the cost will get multiplied by the number of regions, because whatever we are doing in a single region, it has to be done in the additional regions as well. So if you look at the workload cost, uh, it will double and add the storage cost to it. So whatever we had earlier, it will double the cost. Then, as Mark, as you pointed out, the multi-region writes are costlier. So multi-region writes are charged at double the rate of the normal writes. So if we calculate that, it will add on some more throughput requirements. So if you notice this, earlier we had 0.008 USD for 100 RUs per second. This is the unit of our throughput charges. Now this is 0.016. So the dollar cost for your throughput requirements gets doubled if you enable multi-region writes. So I'll switch it back because very few people need it.
Yeah.
So it doesn't make sense doing further calculations with this one. So I have changed the number of regions to 1 and disabled the multi-region writes. Now let's look at workload mode. I'll come back to analytical store later on. If I choose variable, there is, another setting that we have. So it asks me for what percentage of time my workload is at peak. So let's say for 2 hours during the day, my workload is at peak. So I know, okay, 2 out of 2 hours out of 24, my workload is at peak. So that percentage will come out to be 2 divided by 24 into 100, which will be roughly 8.5%, I guess. Is that correct?
I think so.
Yeah,
Yeah.
I think 8.2 or something. So yeah. So if my workload for this example is 10% of the times it's at peak, so this becomes very difficult for users to estimate like how much I'm going to pay if for some period of time only my workload is at peak and I'm tweaking the manually provisioned throughput to increase for that time and then getting it back. So these settings eases of that calculation. And then if you notice, this part changes because now the number of operations in peak hours and the non-peak hours are different. So we need to specify that as well. So let's say that during the peak hours we have 1,000 reads, and non-peak hours, let's say I have 100. And let's leave everything as creates is 1010, updates is 1010, and let's make queries as 0. And if we were to calculate this one, right, so it shows me two different calculations, like what will be the throughput requirement at peak and what will be the throughput requirement off peak. So if I look at these, this will be the throughput requirement for the peak workload, same to what we calculated in the previous use case, and this is off peak. And it gives you the workload cost. If you had provision throughput keeping your peak load in mind, then you might have ended up over provisioning. And it happens a lot of the times. If you uh, if you interview the developers, they often tend to overestimate, and while estimating their workload requirement, throughput requirement, they think, okay, I will put all the peak numbers. And that's when the offering starts looking very costly, because something that is on peak for just 8% of the times, if you extrapolate it to 100% of the times, obviously the cost is going to be 12 times of what you are seeing right now. So this is another important setting here. And like, since the setting is here, it's not related to throughput setting, but I would like to talk a bit about this one as well. Analytical store. So Cosmos DB, normally if you look at the databases, there are transactional databases, and if you have to perform uh, uh, analytics on that, you need analytical store. And if you have to migrate your data from a transactional store to a analytical store, there is a lot of ETL tasks required, and then you can consume it in analytical form. So Cosmos DB makes it very easy. It offers integrated analytical store using Synapse Analytics, Synapse Link. So the there is a simple setting, you can toggle it. And if you wanna see, let me go back to steady again, so and calculate, so that the results are not confusing at all. Yeah. So here we made two changes, steady workload, and we started looking at the analytical store. So there will be some additional cost for the analytical storage. So if you look at it, uh, there will be additional data storage cost, which is 0.02 USD per GB per month. And then there is a transactional cost. If you look at this one, cost of 10K write operations is again very cheap. So for the same workload, the transactional workload, if you were to enable the analytical workload, this is how much you are going to pay extra. And here we don't show the the read cost, because read is very cheap here, and we do put a note here for 1,30,000 130K analytical read operations. The cost is $0.065 only. So it doesn't make sense for us to, put a number here. So we just put a note here.
Yeah, and that's
So
going to happen I mean, that's going to be in a, in a workbook in Synapse. And I'm guessing that also is going to depend on basically the size of the compute you use to do any of those things. I mean, there's lots of variables. I guess what I'm saying is you go down a very slippery slope here very quickly if you
yeah,
start
yeah,
adding in all the Synapse stuff in here. This thing is already pretty comprehensive for estimating your workload costs for row store for transactional store. So I like
yeah.
that you're at least touching on it, but
Yeah, I don't want to go on that route. So let's keep it limited to the transactional workload estimation,
yeah,
because most of the time, to begin with, we'll do that only.
yeah.
So, so yeah, so let me get back to the classic transactional calculation. So we are back here. So if I were to look at recall from our slides, we covered a lot of the uh, parameters that affect the cost, but there are a few more like consistency levels and indexing policy, which we do not expose in the non-signed-in version, because then it becomes too complicated for the end
Mhm.
user. As is like you can go from one level of complexity to the other here itself by specifying variable and all. So if I were to sign in, I will see that additional fields here. So I'll not go in the detail here, Mark. Maybe this is the last section that I wanted to cover for today. Uh, if you look at here, there are additional settings related to consistency level. So we have 5 levels of consistency, and the default one is in the middle, the session consistency. Uh, the ones below that, they do not change the cost. It's the same as the session consistency level, but the bounded stillness and the strong consistency level, they will I guess double the cost, as
Yep.
you mentioned earlier. And then we have indexing policy. By default, in this calculator, we keep it off. uh, we can choose to automatically index. So when we choose automatic indexing, we are essentially indexing everything, all the fields. And then we have an option to specify custom indexing policy. So if you have custom indexing policy, you can put it here, and then the calculations will happen automatically. I will not go in the details here. So another thing, extra feature in the the I missed out on the non-signed in version, which is there itself. You can add the item. I talked about this teacher and student items, right? So there might be more operations on the student items as compared to teachers items. So this tool also gives you flexibility to add another item. So I can specify, okay, for teachers item, let's say there are 50 point reads, but for student item, let's say there are 500 point reads. So we can specify more than one items, and specify the uh, number of operations on those items separately, so that we have a fair idea. Otherwise, what happens again, the developers, when they have to estimate their workloads, uh, they will go for the worst case scenario. So let's say the students item, it's getting 500 reads per second. So for all of their workload, they might either set 500, or they might take an average number. So this setting, this option of adding more items and then specifying the number of operations, it gives that flexibility that you can uh, specify number of operations for different items and calculate the cost
Yep.
accordingly. Yeah.
And
So
we'll
that is,
actually take that document and kind of test the document itself, don't we?
yeah,
And run
yeah.
that
I,
thing?
I,
Yeah.
yeah, I actually missed on that part. Thanks for pointing that out. We also have this option of, uploading the document. So Cosmos DB, it stores in the JSON format. So if you have any JSON document that you'd be storing in Cosmos DB, the items will be in JSON format. So you can upload that file here, and we can automatically calculate the size and the number of properties that
Yep.
gets
And you can
populated here.
use that with a custom indexing policy as well. So if you want to get really precise
Exactly.
on what your cost is going to be, just upload a sample document, do your custom indexing policy right there. Yep, you're showing it,
Correct.
and then you can get a really dialed in estimation on what your cost is going to be for doing those operations on there. So again, you'll have to the query one you got to kind of estimate on there, and really, I think it's just I mean, for me, I just go and I just write queries in Data Explorer and then just get the cost out of there, and that's kind of how I do my.
Yeah, yeah, yeah.
I think most
For
people do kind of do
yeah,
that.
for
So
query, it is always recommended that you execute a query and then get the average cost.
yeah,
Yeah.
very
So
cool.
yeah, that is all I wanted to cover with this capacity calculator tool, Mark. Are there any questions? Uh,
No, I just this is a tool we've had this around. We've had this around for many years, and it just keeps getting better and better.
yeah,
You've done, I know you've done some great work on this thing as well,
yeah,
and there's always more. There's always more to do there. So yeah, fantastic stuff. I've got the link up there for people that want to hit it. You should definitely bookmark this thing. It's very handy when you're trying to bring on a new workload and just trying to get some kind of handle on what your cost is going to be. Because, like I said, it's we kind of front load a lot of stuff that you kind of have to have your head wrapped around when you're designing and building and deploying applications using Cosmos. This tool here is just try to help you just get a better handle on that and just allow you to kind of do some better capacity planning around that there. So hey, Abhinav, great having you with us this week. Is this the first time on the show? I think
yeah,
maybe.
yeah. It was my first time. I
All
was kind of
right.
nervous,
Hey,
Mark.
that's fantastic. Everything was just good and smooth, just the way it should be. So, hey, thank you so much. Great having you on. Hey, folks, join us every month for our virtual Cosmos DB user group. New speakers from the community every month with lots of great topics on how to build applications and services using Cosmos DB. Check out all of our past episodes up on YouTube, aka.ms/Azure Cosmos DB Live TV. Abhinav, thank you again for joining us, and
Thanks so
definitely
much,
come
Mark.
on back. We got have you back on the show, talk about other stuff.
Yeah, I'll be back soon. I have something planned.
Sounds great. Sounds great. All right, folks. Thank you, everyone. We'll see you next time.
Yeah. Thanks so much.